Imagine a place where gravity is so powerful that not even light, the fastest thing in the universe, can escape. A place where space and time themselves bend beyond recognition. Welcome to the fascinating world of black holes. Once considered purely theoretical, black holes are now among the most exciting objects in modern astronomy. In this presentation, we'll uncover how black holes form, explore their incredible structure, learn how scientists detect them, and separate scientific facts from popular myths. By the end, you'll understand why black holes continue to challenge our understanding of the universe. A black hole is not an empty hole floating in space. It is an incredibly dense object where gravity has become so strong that nothing, not even light, can escape once it crosses the event horizon. Since black holes emit no light, they are invisible. Scientists detect them by observing their effects on nearby stars, gas, and light. Although we cannot see a black hole directly, we can clearly observe the powerful influence it has on everything around it. Most black holes begin their lives as massive stars. During a star's lifetime, nuclear fusion balances the inward pull of gravity. But once the star runs out of fuel, gravity wins. The core collapses violently, often triggering a spectacular supernova explosion. If enough mass remains, the core collapses into a black hole. Black holes can also grow by merging with other black holes or by consuming surrounding matter over billions of years. Every black hole has a story. It begins inside a giant cloud of gas called a stellar nebula. Gravity compresses the gas to form a massive star. After millions of years of burning nuclear fuel, the star expands into a red supergiant. Eventually, it explodes as a supernova, scattering heavy elements across space. If the remaining core is more than about 3 times the sun's mass, gravity compresses it into a black hole. The death of one star often provides the building blocks for future stars and planets. A black hole has several fascinating regions. Surrounding it is the accretion disk, where gas spirals inward, heating up and emitting powerful X-rays. Some black holes also produce enormous relativistic jets that shoot particles across millions of light years. The photon sphere is where light can briefly orbit the black hole. The event horizon marks the point of no return. At the center lies the singularity, where matter is compressed to extraordinary densities, and our current understanding of physics breaks down. Black holes come in different sizes. Stellar black holes form from dying massive stars and typically contain several times the sun's mass. Intermediate mass black holes are much larger, but remain difficult to detect. Supermassive black holes contain millions or even billions of solar masses and sit at the centers of galaxies. Scientists also propose primordial black holes, which may have formed shortly after the Big Bang, although none have yet been confirmed. Stellar black holes are the most common type known today. They form when massive stars exhaust their nuclear fuel and collapse under their own gravity. Most have masses ranging from about 3 to 100 times that of the Sun. Famous examples include Cygnus X1, one of the first strong black hole candidates ever discovered. These black holes often exist in binary star systems, where they pull matter from companion stars and emit intense X-rays. Intermediate mass black holes bridge the gap between stellar and supermassive black holes. Although rare, astronomers continue to search for more evidence of them. Supermassive black holes, however, dominate the centers of galaxies. Our own Milky Way contains Sagittarius A star, a black hole with about 4 million times the sun's mass. These giants influence the motion of stars, regulate galaxy evolution, and power some of the brightest objects in the universe. Several black holes have become famous through scientific discoveries. Sagittarius A star lies at the center of our galaxy. M87 star became the first black hole ever imaged in 2019 by the Event Horizon Telescope. Cygnus X1 remains one of the earliest confirmed stellar black holes. TON 618 hosts one of the most massive black holes ever discovered. Studying these remarkable objects helps scientists understand how galaxies form and evolve. Since black holes emit no visible light, scientists detect them indirectly. They observe stars orbiting invisible objects with enormous mass. They measure powerful X-rays from hot gas spiraling into black holes. They study gravitational lensing, where black holes bend light from distant objects. And today, gravitational wave observatories detect ripples in space-time produced when black holes merge. These methods have transformed black holes from theoretical predictions into observable cosmic realities. When two black holes spiral toward each other, they release enormous amounts of energy as gravitational waves. These are tiny ripples in space-time predicted by Albert Einstein over a century ago. In 2015, the LIGO Observatory detected these waves for the first time, confirming one of Einstein's greatest predictions. Today, gravitational wave astronomy has become an entirely new way of exploring the universe. In 2019, scientists achieved something once thought impossible. They captured the first image of a black hole. Using the Event Horizon Telescope, researchers photographed M87 star, revealing the glowing ring of hot gas surrounding its event horizon. In 2022, they also released the first image of Sagittarius A star, the supermassive black hole at the center of our Milky Way. These images marked a historic milestone in astronomy. Gravity affects not only objects but also time itself. According to Einstein's theory of relativity, clocks closer to a massive object tick more slowly than those farther away. Near a black hole, this effect becomes extreme. Minutes experienced near the event horizon could correspond to years for someone far away. This phenomenon, known as gravitational time dilation, has even been observed on a much smaller scale using satellites orbiting Earth. The answer depends on the size of the black hole. Near a small stellar black hole, the difference in gravity between your head and feet would stretch you into a long, thin shape, a process known as spaghettification. Near a supermassive black hole, you could cross the event horizon without immediately noticing anything unusual. However, escaping would become impossible, and what happens beyond the event horizon remains one of science's greatest mysteries. For decades, scientists believed black holes could never disappear. Then, in 1974, Stephen Hawking proposed that black holes slowly emit tiny amounts of radiation due to quantum effects near the event horizon. This process, called Hawking radiation, causes black holes to lose mass extremely slowly. Although it would take far longer than the current age of the universe for large black holes to evaporate, Hawking's idea forever changed our understanding of these cosmic giants. Many myths surround black holes. They do not endlessly suck everything in like cosmic vacuum cleaners. Objects at safe distances can orbit them just as Earth orbits the Sun. Our Sun will never become a black hole because it lacks sufficient mass. Black holes are not giant holes in space. They are incredibly dense concentrations of matter. Understanding these facts helps separate science from science fiction. Black holes are much more than cosmic curiosities. They allow scientists to test Einstein's theory of relativity under extreme conditions. They influence galaxy formation, power energetic cosmic jets, and may hold clues to combining quantum mechanics with gravity. By studying black holes, researchers hope to answer some of the biggest questions about the origin, evolution, and ultimate fate of our universe. Black hole research is advancing rapidly. The Event Horizon Telescope continues producing better images. Gravitational wave observatories detect new mergers every year. Space telescopes such as the James Webb Space Telescope are helping scientists understand how galaxies and their central black holes evolved together. Future discoveries may even reveal whether primordial black holes exist, or provide new insights into dark matter. Did you know that time slows down near black holes? Or that supermassive black holes can contain billions of times the sun's mass? Black holes cannot suddenly swallow Earth because none are close enough to pose any threat. Scientists still don't know exactly what lies beyond the event horizon, making black holes one of the greatest unsolved mysteries in physics. Black holes remind us how extraordinary our universe truly is. Born from collapsing stars and growing into galactic giants, they continue to challenge our understanding of gravity, space, and time. Every new discovery brings us closer to answering some of the deepest questions in science. Thank you for joining this journey, through one of the universe's greatest mysteries. If you enjoyed this video, don't forget to like, share, and subscribe for more fascinating explorations into science and space.